All right, so in this video, I'm just gonna go over the second half of our digital fabrication module, which is on 3D printing. You may recognize here the folder that I'm in. This is from our second module where we were working with photogrammetry. And this is directly out of the PhotoCatch app, a scan that I did at Gasworks Park. So I'm just gonna right click, open with Rhino 7. The example I'm using here then is a mesh model, which works really well for 3D printing. Double click here. This may look familiar to you at this point. I'll just go right click rendered and we will change the orientation. So if you recall this model, it's not scaled at the moment, and I'm gonna do a couple different methods in terms of how to start to get this mesh model, which right now is an open mesh. You can see over here how to get that into a 3D printable mesh model type. The first thing I'm going to do is go ahead and go into my shaded, and you're going to want to crop some of this for yourself. I'm just using a circle here, and I'm going to extrude that up. This is not unlike what we were doing with the CNC milling operation where I made a box. So that looks pretty good to me. I think I'll go with a circle, and I just want to make sure I leave enough room for these legs right here to not get caught. So maybe we'll go back a little bit. You can see here, these are the legs I'm talking about. You could also just scale this up slightly. And why don't we go with that? I'm going to type mesh trim. Mesh trim up here as well. And I'm just going to hit enter. And so here is the model that I would like to 3D print. Couple things. The first would be to take a look at the scale here. So if we do 6 inch by 6 inch by 6 inches, that's sort of a somewhat standard 3D printing bed size, at least to get us roughly to a scale that we may want to print at. Just scaling that up. And I could hit Control Shift just to delete that out to get a sense of this fit. So yeah, that'll be pretty good. So that's fine. That was just a rough kind of like test for the size. Now you can see this is kind of canted on an angle, so you may want to adjust that, potentially even in a kind of side view, zoom extents all. And so you could take a look here at getting it to be somewhat flatter. Something like that might work a little bit better. So that would be the very first step. The other thing we could do when we go into the file folder, we'll go back to our assignment 3, where we've prepared a CNC model, if you remember. So the difference here was this, here we're using a surface, and we're using now to 3D print a mesh. So there's a difference in terms of the object type. But the reason I open up this file is simply for us to potentially copy this over and start to think a little bit about how these two drawings may interact or not. So they don't need to be at the same scale. This is sort of up to your project in terms of what you may want to do or not. You could be that this secondary object is worlds larger and you're starting to tell a story about the sort of post-industrial landscapes or relics in the landscape and how they define it. There's something interesting here, even at how I pasted it in, about this very large mound at Gasworks and how that may be dwarfed even by the architecture, the relic that remains. Or you could start to scale this down. That would need some analog fabrication after to really get it to fit well. But you could start to scale this down and really think about this, like how this may start to fit into your foam, assuming that that's what you're fabricating with here. And once you're kind of happy with a rough test fit, something that may fit somewhat well and like has a decent scale for you, even if it is something just like this, this base is something you could potentially break off of the model. You could cut it out. Lots of options here for you. Or you could find a way to just sort of regrade part of your foam and have this sit on top, or use some sort of adhesive to have it sit. But in any case, if it's something like this, that might be pretty good, right? The point here is that you're taking your 3D printable object, or the object that you want to 3D print, and bringing it in the context of your CNC milling project. So the two are meant to be in conversation with each other. Now, whether you use some kind of dowel and have this floating above and it's actually a more abstract model, all these things completely up to you in terms of how you work this out. But this moment in this demo is just to have you think a little bit about the relationship of these two objects to each other. So I'm just going to hit Control X for cut, and I'm going to go back to this drawing file, simply because now I have a scaled version. Delete that previous one. So now I'm happy with the size of this relative to my other drawing, my other digital fabrication piece, which is the site topo. I've just moved this to the origin 0, 0. And so there's a couple different things you can do. We're going to be working with the UltiMaker Cura. So I have that downloaded here. If I type Cura right here, this demonstration is not going to be unlike the CNC one that you're maybe watching previous on this sort of sequence of tutorials. But in essence, we're not working with the UltiMaker original. We're actually working, the lab at the College of Built Environments at the University of Washington is actually going to be using the UltiMaker 3. And so just know that you'll actually be doing these settings in the lab in terms of choosing your PLA, choosing your, if we go down here, choosing your support type, which will be a breakaway that we have purchased. So all those parameters, not unlike the CNC milling with setting your bits and things, that will be done in our fabrication lab at the college. But this is more just to make sure you have a workable mesh and how to really start to prepare that mesh. And so the first thing I could do, just for the purposes of this demo, is, let's say you're happy with this. The first, in some ways, red flag would be that this is an open mesh, but why don't we go ahead and export this just so you can kind of see what happens. Export selected. We're going to want to export this as a stereolithograph here, STL, and we'll call this test1. You want this to be a binary file, so that's all good. And export open objects, we're going to have checked because our object is open. So there we go. File successfully saved to my desktop. Assignment 3 folder. Over here, desktop, assignment 3, test 1, open. Right away, you can see there's model errors, right? The highlighted areas indicate either missing or extraneous surfaces. Fix your model and open it again in Cura. So you can see there's a lot going on here. Lots of errors. This is just to show you that that is the case for this model. So you're not going to be able to slice this, which would be the start. I'm just going to go ahead and select this and hit delete. Now, the first thing that you can really start to play around with when you're preparing this mesh for 3D printing would actually be to offset the mesh. So offset like you normally would, but specifically here, it's a mesh that you want to offset. So give that a click, solid yes. And you know, this may look a little bit confusing at first because there's a lot going on here. Just know that you can type 1 millimeter, something like this, right? And enter. And you can see now that this is offset everything 1 millimeter. In this case, this now has a kind of thickness. When I click on this, you can see it's now a closed mesh. Now, that's not to say that that is going to solve all your problems as well. Like 1 millimeter is kind of the limit of like thickness or really thinness, I guess, for 3D printable. It's likely this should just become solid potentially. So what I want to do is just demo a couple really quick troubleshoots. So you can see here, there's 2 meshes, right? This is the previous open one, just to give you a sense of the difference. Hit delete on that. We'll call this one file, export selected. Call this test2. Same thing, you can see that file size is not that 6 megabytes is very big, but just to give you a sense of some of those implications. Now this is still going to be a fairly problematic mesh, but again, I'm just going to hit X on this and show you, some of the workflows and issues you may run into so far. But why don't we hit slice? Right, so here, slicing failed, slice failed with an unexpected error. I'm not going to report the bug because it's likely that, well, we can kind of see some of these faces and issues. Now, in my opinion, the quickest troubleshoot when you're running into these issues where you need to repair your mesh is, let me just close out of the CNC one, is that, you can try to come in here and rebuild the mesh. You can, or sorry, not rebuild, repair the mesh repair, there we are. But this becomes very tedious where you hit check the mesh and it lines out all the issues for you. What I would recommend is going online. Now, I've sort of done this for you, and these change all the time. These get purchased by companies. And so this is one that remains at the moment free. It's a free online STL repair. So this is FormWare, FormWare.co, and I'll share this link in our course canvas. But essentially what you can do here that's really fantastic is you can upload an STL file. We could even do it with the very first one. So why don't I start with that one, the one that really, really wasn't working, test one. And you can see the upload happening here. So I'm in a queue, I'm waiting behind sort of one person. And if this takes beyond 4 minutes, then essentially that means it's not repairable in that time. So this would be, if you have a very large file, you may run into this kind of timeout. For the purposes of this recording, I'll likely hit pause until this is done. You do have to wait. It's a free service to repair your STL. But let me hit pause and I'll circle back once this is done. All right, so you can see here, this took just under 4 minutes to repair. Granted, I had one person waiting in the queue. So 975 naked edges were fixed. 2 non-planar holes were fixed. The repairing is 100. You can see here a before-after image. So specifically, the biggest issue we had was the variability in the ground plane, which has been cleaned up, as well as these broken areas for our post-industrial relic. And so here you can just download the fixed STL and that'll download for you. So I would definitely recommend FormWare. At the moment, these things change pretty quickly, but this is proven to be a really fantastic resource. From here, you can go into your downloads and just grab that test one fixed and put that into whatever folder you like. For me, this will go into our third module. So that's test1_fixed. From there, we can go back to our Cura, go into that folder, test one fixed, open. And you can see now how this has sort of repaired this top piece, especially, and the ground plane for that matter. So why don't we go ahead and try slice? Depending on how long the slice takes, I may hit pause. It often gets to about the midway point, and then there is a fairly large lag. So I'll hit pause and circle back, and I'll let you know what the load time was on this. All right, so that wasn't too bad. You can see here 1 hour and 54 minutes. That's the printing time. The loading time took about 2 minutes, just under 2 minutes. So not too bad to compute. What you can do at this point, remembering that of course the purposes of this demo is not fully to set up the file, it's really to get you to do a trial version and just make sure that when you take this to your lab, it is printable already so that you're not having to revise the mesh itself. You're just going to program in things such as the infill density. So that is one of the settings. 20% specifically is what was recommended, as well as the stock feature of 0.8 for the shell thickness, the kind of print core size. A couple things we can do is preview. And so you can see here, I actually have already preset the supports on. You could turn those off, and that'll change your slice setting. So let me just do that first with the supports off, and let's hit slice once more. All right, so that without the tree information, in terms of the support that is, it's an hour and 12 minutes. Now, as we kind of scroll through this, we can see the different printable layers here. And so this is kind of how it'll print for us. All the way to here. And you can see what some of that fill will look like here. It looks like the material estimate is about 3 grams. So that would be pretty good. Let me go back to support because there are overhangs here. So I would recommend adding some supports. Now you can do normal or tree. I'll show you tree. You will have to slice this again. Hit OK. All right, so you can see the print time here is 1 hour and 53 minutes, and we're using 6 grams. This is that tree support. That's going to make sure that this part doesn't fail as we print this. You can take a little look around. And we can also just kind of scroll through here. And this is something you'll want to double check at the lab and have a bit of a discussion with the lab tech just about print time, whatever you're getting for print time, the amount of material use, as well as the different settings, because you are going to want to essentially change out the type of filament you're using. Let's say like there's breakaway, which is what you want to use for the supports, the tree here. But then for the rest of this, you'll want to use PLA, which again, you have the choice of clear, white, or orange. And those you'll have to set into your model. There'll be different extruders that you have to select. Just keep in mind, I'm using the UltiMaker basic version here. So at this point, I would go into the lab and bring your STL file into the UltiMaker Cura that they have in the fabrication lab. And you'll have to fine tune your settings there in terms of your different filaments, different extruders, that you're using breakaway for your tree and that you're using PLA for your primary extruder. And from there, you'll want to just double check your patterning for infills, which is kind of your choice. And at that point, what you'll end up doing once you have all the parameters set within the lab's UltiMaker Cura, you'll save to disk. And the G code is what you want. Specifically, you're going to be saving this onto your USB. So make sure you have a USB that you're very comfortable with in terms of just leaving it overnight, or for at least in this case, a couple hours. I'm just going to save this here. Leave yourself some time for failures. There's a lot that can go wrong with the 3D prints, from your own file input all the way through to just simple spools getting tangled or clogged, and errors more on the machine's end, let's say, rather than the data end. So let's leave it at that. That should conclude everything that you need to know in terms of just the 3D print file prep and some of the logics that you'll go through in terms of the troubleshoot. So hopefully that gives you a good sense of kind of how to start to think about this second part of our digital fabrication module and how that might integrate into your CNC model, as well as your kind of narrative for your project study site.